Okay, kia ora. Welcome everybody. Tēnā koutou katoa. I'm Amy. I'm the CEO of the Passive House Institute New Zealand, or Te Tapatanga o Te Whare Koro ki Aotearoa, which means the Houses of Vitality. And speaking of which, I'm pleased to say that as we speak, the wall elements of my own passive house are going up. So that's exciting times for me. So thank you so much to Daryl Sang Architects and to August Millard, and also to the owners of the Wunderbar Passive House who have agreed to do this webinar with us today. It's a great opportunity to share learnings. We will be doing questions at the end, but feel free to pop questions and chat in those boxes as we go. And we'll try to leave 20 minutes for questions at the end. And there will be a recording available of this webinar afterwards. Also, if you have questions that you think of at the end that you didn't get a chance to answer, please send them through to us and we'll do our best to come back to you on that. So I'm going to hand you over to Daryl August of August Millard to get us started. Thanks very much, Daryl.
Thanks, Amy. Welcome everybody, and special thanks to Fins for hosting this today. It's great to sort of do something collaboratively with the industry. I thought I'm going to speak for a couple of minutes just to sort of introduce August Millard and our involvement and where we kind of fit into things. So this is us, August Millard. We are sorry, I'm just trying to get control of this. So we're a building consultants. We specialise in building surveying and project management services, and we've got experience in New Zealand and in the UK, pretty much providing professional services to the property and building industry throughout New Zealand, and it's both in commercial and residential property. And we have an office in Auckland, which is our head office, and a satellite office in Wellington. And there's just a few clips here of some of the things that we get involved in. And I think some of the audience will know what building surveyors do, and some of the audience probably are not sure what building surveyors do. I'll switch on to the next slide. In terms of, sorry, going back, in terms of sort of our background, and building surveying roles. So one of my other roles in the industry is I'm currently the Vice President for the New Zealand Institute of Building Surveyors. So I thought I would touch briefly on some of the roles that building surveyors play. A lot of people in New Zealand would see building surveyors more dealing with weather tightness issues and leaky building investigations. However, if you look at the UK, building surveyors cover a much wider breadth of services, commercial building surveying, pretty much quite different to what we do in New Zealand. In terms of the New Zealand Institute of Building Surveyors, we're a membership of roughly 230 members throughout the whole of New Zealand. Sorry, for some reason my screen's changed. Throughout the whole of New Zealand, and we as an institute also offer training, and that training helps to develop our junior building surveyors and some of our members that come in from other areas of the industry like builders, etc., who want to retrain. So we have our 14 module system that allows you to then go through to become a registered building surveyor and obtain a diploma in building surveying. A little bit of history, building surveying dates back to, I think it was 1869 in the UK, when the Royal Institution of Building Surveyors was formed. So it is an old profession that's been around many, many years. In terms of August Millard's involvement with passive house related items, we first became involved through an insurance company that we do some assessments for, and we were assessing a builder who was a passive house builder. And we suggested to the builder at the time that it might be quite good for them to have some peer review processes done of their drawings prior to going in for a building consent, which they adopted. and help them to process their building consents. And the local authority that were processing, I think, appreciated that. And that company was Isodome. We formed a bit of a relationship with Mike at Isodome, and that led us to the current project we're dealing with. In terms of what Ian is going to cover off later in the webinar, we undertook a peer review on the project he's going to do the case study on, but we also did a previous one for a project in Wellington a few years back. Slightly different type of window system, but a window system out of Germany, where we had to do the same process again, as to show the local BCA the compliance pathway to be able to ensure that it complied with the New Zealand Building Code, which obviously it did, but they needed that documentation to back it up. So that's really where we fitted into it, and keen to be involved in a lot more of these types of houses, and looking forward to this webinar today. So that's probably enough from me, and I'll pass it on to, I think we're going to Daryl next.
Yes, yes, thank you, Daryl. My name's Daryl Sang, and I have Alia Abid Ali with us on the webinar, and we're part of the team from Sang Architects that have worked on this particular passive house project. It's a new build passive house residential property, and it's known as the Wunderbar passive house, located in Orewa in Auckland, and it's aiming for the Passive House Classic certification, as well as Homestar 8 or 9. So our presentation today is just really a short one, just outlining this project, and a brief discussion about the overall design specification and the materials we're using, and then we'll hand over to Ian Fong, who can talk a bit more in detail about the process that August Millard had to go through to get the windows certified. So let me just go to the next slide. Does that happen for me? Oh yes, here we go. Okay, so just a little bit about Sang Architects. I'm Daryl Sang, so I'm the director, and I have a background in as an architect as well as an engineer. I'm registered here in New Zealand, as well as registered as an architect in the UK after working there for a number of years. And I'm also a certified passive house designer. And Alia Abid Ali, she's a senior architectural graduate in our firm. We have a team of 5 of us, and we have certified passive house designers on staff. So we can provide the whole package of the architectural design and detailing, as well as integrating passive house. And our mission is for all our projects to be passive house. And we are most of the way there. Most of our projects are passive house or high performance. So that's wonderful for us and for our clients. And so what's the difference between passive house versus what we call active house? That's kind of a minimum building code type house. What's the big differences? So this is an A4 download from our website, which just explains that a passive house really is a building that will keep you warm and comfortable throughout the year, no matter what the weather outside is doing, using very, very little energy, 90% less energy than a standard minimum building code house. Keeps you warm and comfortable all by itself. Temperature generally between 20 degrees up to 25 degrees all year round, just because it's really well insulated, continuous insulation all the way around, with no thermal breaks or thermal bridges. It's going to be airtight. It means it doesn't leak a lot of air through the windows or the walls or the roof or the floor. and it doesn't have thermal bridges. That is parts of the building that leak a lot of energy, bypassing the insulation layer. And it has really good ventilation. It has continuous ventilation, mechanical ventilation with heat recovery. So it brings in fresh air, gets rid of the stale air, but also hangs on to all the heat of the indoor environment. Yes, gets rid of all that extra moisture, so and avoids all that condensation and mold, and gets rid of all the CO2 and toxins inside. And it also controls vapor through the building envelope. It's airtight, but it's not vapor tight. It allows the wall structure to breathe. Let's have a look. That slide seems to be changing itself. But there we go. So anyway, that was the bit about what's the difference between passive house and an active house. Doesn't do those things. It tends to be cool and drafty, and it leaks a lot of heat and a lot of air, and you still can get condensation and mold on the inside. So let's talk about the Wunderbar passive house. So on a site in Orewa in the north of Auckland, it's a site in a new subdivision, 471 square meters, so a reasonable size but compact site. It has a slope on it from High Point at the rear down to the street. It faces north, and it's in a very high wind zone. Residential single house zone, so only one house, one residential unit on the site, and it's also subject to some planning regulations, particularly related to the Orewa area, and it's in the H5 residential mixed housing zone under the Orewa precinct. And it also is a new subdivision, so it's subject to the Sunny Heights subdivision design review panel. So there's a few planning restrictions around that. So it's, as I said before, it's a new build house. Basically, it's a concrete house design, 255 square meters in floor area, plus 45 square meters of garage, 2-story, 4 bedrooms with 3 bathrooms. The main structure is Isodom. It is the Isodom insulated concrete formwork walls, 250 mil thick. That's 250 mil skins of polystyrene with 150 mil solid concrete reinforced core. Isodom system's actually passive house certified, so we know it's been analysed and certified to be up to the passive house standard. And that's the whole system. We're using the concrete ICF formwork walls. We have the Isodom insulated foundation system. That's the certified, passive house certified floor slab. And we're also using the Isodom mid-floor slab system. So as a package, that is a fully passive house certified system. So we know it's going to perform, and we know that the thermal bridges have been thought about and reduced or eliminated. The garage slab itself is outside the thermal envelope. There's a garage on the lower level that is outside the thermal envelope, but it's thermally separated from the main house. And we're rendering the whole of the outside of the house with a stove plaster system. And the high performance windows are Gielan Fenster S9000 UPVC triple glazed windows in there, again passive house certified. And we also have an external aluminium shutter system to provide extra shading for some of the windows that are going to be subject to quite a lot of sun. And the roof is just long run colour steel. And we're due to start on site very shortly. So just a few images of the house on the site. So this is from the street, standing on the north boundary of the site and looking back up the site. So you can see we have a sloping site, so we're partially retained into the site. The garage on the ground floor, and there's a bedroom suite on the right of the ground floor, and then upstairs facing north are the living areas, living, dining and kitchen areas. And that's a site plan there. This is the street on this side here, and on the left-hand side of the plan, this is kind of the garage and that bedroom downstairs, partly retained into the ground. This is the high back of the site, and there's some retaining. And there's some retaining at the back. And then upstairs we have all those main living areas and that deck looking out over that the street, and then 3 bedrooms at the back. Again, that just shows that that ground floor in more detail with the garage and that living room. Sorry, that bedroom downstairs, and then here the living areas and the 3 bedrooms at the back, and just the second living area here. So, and today we're focusing on the high performance windows. So we have some window details here, and Alia is going to step in and just discuss these. Thanks, Alia.
Thanks, Daryl. Thanks, Daryl. Good afternoon, everyone, and welcome. So I'll start off by talking about the facade details, which were prepared as part of the building consent documentation, and then move on to briefly discuss the scope of work addressed in building control authorities' request of further information, and then the compliance framework followed to achieve approved facade details, before handing over to Ian Fong from August Millard. So as Daryl has explained, the external walls are constructed of a proprietary Isodome 250 system with 150 millimeter reinforced concrete core, infill, and 50 millimeter neopore polystyrene insulation on both sides. The neopore blocks are used to make the structure or the formwork of the walls and to insulate it as well. Wieland Fenster S9000 UPVC windows were specified for the project in combination with ALA-proof SKT external aluminium roller shutters for all bedrooms and north-facing window openings in order to eliminate the potential overheating during the summer. So as you can see in detail 09, which is a combination of the window head facade detail and the windowsill facade detail, the window head detail shows the Isodome lintel block labeled L3 with reinforced concrete infill as designed by the structural engineer. The top mounted roller shutter is fixed to the UPVC window, and this is factory installed through flat stainless steel bars to each side of the window frame. Then the shutter box itself is directly fixed to the lintel structure through stainless steel straps, providing a stable connection between the window frame and the lintel through the shutter box. For the window openings, we have allowed for an all-round 10 millimeter gap for the expandable tapes, except for the sill where the window must sit directly on the load-bearing structure, also to eliminate the ponding resulting from timber packers. In addressing potential thermal bridging, as you can see in the head detail, we have allowed for a 30 millimeter XPS multi-form board glued to the face of the ALA-proof shutter box, and this is to prevent any cold or moisture penetrating the structure. Also in the window head facade detail, we have allowed for a stow UPVC base cap, which is suitable for the rendering system. And this is proposed to protect the bottom edge of the XPS insulation, replacing an originally proposed corner metal flashing. This is to comply with E2AS3 for weather tightness and also ensure the compatibility with the render system. Daryl, if we could please move on to detail 03. So detail 03 is a windowsill facade detail at the junction of the first floor timber deck. And here a rebate was created within the structure by cutting out 50mm neopore insulation to allow for the direct structural fixing of the deck stringer to the concrete lintel. However, we have allowed for 20mm Knauf insulation XPS foam board in between the H3.2 SG8 packers at the face of the isodome mid-floor. And this is to eliminate thermal bridging while maintaining the structural integrity of the fixing in this detail. We have also allowed for stainless steel flashing behind the deck stringer, allowing for 10 to 13mm drainage gap between the stringer and the flashing, formed by installing 13mm thick packer to prevent water penetrating the structure through this rebate. Also, as you could see, we have allowed for the bottom edge of the stainless steel flashing to have a 50mm minimum lap cover over the face of the cladding, which is also typically required as a weather tightness compliance. At the junction of XPS EPS system with the timber joist, the render system will be finished with a UPVC finishing edge and a sealant joint over PAF rod to help minimize the issue with shrinking and timber movement, i.e. stow would not be in direct contact with the timber. So just moving very briefly onto the scope of work addressed and raised by building consent authorities. The council has actually requested the following information. A was the evidence of window wind load testing data as it relates to site-specific window wind speed, which is a very high wind zone. This will be discussed in further detail by Ian Fong. They have also requested a detailed verification of the weather tightness testing for Gielan windows, addressing issues of water penetration. And finally, they've asked for the provision of supporting documentation in addressing the weather tightness of the joinery cladding junction, which, as described in the RFI by Council, was further complicated by the combined application of a top-mounted roller shutter box. In terms of the compliance framework, we commenced the facade detail verification process with an in-depth discussion with August Millard as they prepared a detailed design review for the window joinery. We also engaged Proclima, Stowe, Isodome New Zealand, who were the passive house builders and project managers for the project, in order to ensure the compatibility and the buildability of the systems recommended by suppliers and consultants, while adhering to passive house standards in terms of airtightness, thermal performance, and the prevention of cold bridges. So the compliance of the selected Gielan S9000 and Alloproof shutter system with E2 external moisture was assessed under NZBC E2AS3 for concrete and concrete masonry buildings. And the final facade details issued by SANG Architects were produced at 1:2 scale, also color coded as requested by Building Consent Authority. They were joint reviewed and approved by August Millard, Proclima, and Stowe. Just very briefly at the end, I'd like to mention that critical to the discussion with Proclima was the release of their latest assessment report on the 17th of May 2021, where Tesco Nextora sealing tape was approved to meet the performance requirement as a primary air seal as a tested system for extreme wind pressures covering most residential projects. So the Tesco Nextora profile tape was recommended for use in the project, both as an external weather tightness and internal air tightness flexible window membrane, and also as an air seal. And this has helped in eliminating the use of expanded foam and sealants as joinery air seal solution for this project. So now I'm going to hand over to Ian Fong to discuss the wind load compliance framework and also E2 weather tightness compliance path for the project in further details. Thanks, Ian.
Yes, good afternoon, everyone. Thank you for joining as well. I'll just carry on from where Alia had stopped off. All right, let me just get the slide up. Here we go. All right, so I'll just carry on with this case study. Sang architects have already talked about the site where the building is located, the profile of the building, how it's constructed. So I won't cover that. I'll focus more about the RFIs that we were asked to deal with. And then what I'll focus on mainly is the process of resolution, which compliance pathway is suitable, the alternative solution, what sort of evidence we had to provide. And then we'll talk about the acceptance of the joinery units in terms of compliance, and finally just a peer review of the weather tightness details. Now, I think I should also acknowledge and thank Andreas Goetz, the house owner. He's been supportive of passive houses, and we did ask whether we could talk about his house, and he was more than happy to allow us to share our experiences with it. I also have a personal interest in passive houses. I think Daryl August, my boss, knows clearly that during summer I'm the one wearing a puffer jacket, so I like buildings to be warm as well. The warmer, the better for me. Of note is that when I first got into looking at thermal performance, windows in particular, I think joinery, they account for about 8 to 10% of the thermal envelope. However, the heat losses from windows is up to 40%. So it's important that windows are done right, I guess, for passive houses. So I guess also from a building surveying point of view, we are interested in getting houses done right because of we know that inside the building there's a lot of moisture as well, a lot of condensation from whether people are drying clothes or activities within the house. And with a relative humidity of above 70%, usually going to get mold. So it's not just about cold, but also the dampness within houses. So with that in mind, that's some of the things we looked at in terms of performance. But coming now to the RFIs, well, I think Gerald Sang also mentioned clearly in his slides that this particular building is in a very high wind zone, and that is particularly important in terms of working out the compliance performance standards that it needs to meet. So when we looked at, for example, if someone asks us, can you give us approval for window compliance or give us a review of it, the first thing we'll ask is, where are the windows installed? What type of building, and where is the building located? So that's the first thing we try to work for, because we have to provide something that is fit for purpose, and I believe council officers are of the same mentality. All right, so these are the RFIs that I think was briefly touched on by Alia and Daryl Sang. So there were three elements. The joinery element itself, I guess it's to do with council. They're not familiar with this product. They needed to know, okay, you've got shutters that's going to provide some shade, and those shutters are attached to the joinery. The joinery we're not familiar with. It's an imported product as well. So you need to tell us that the joinery is something that's suitable for use in New Zealand, and in particular in this particular location. And then the RFIs related to them being unfamiliar with it is also when they ask questions about, okay, water gets in, how does the water get out? What's the drainage features? Where's the evidence to show that this product will allow water to drain out? And then the last one is obviously to do with weather tightness, because they're not familiar with the product. They don't know how it fits into this particular building, which is concrete formwork, insulated concrete formwork. So it's about going through, which I'll go through now, and working out, firstly, understanding where council are coming from, understanding what the issues were, and then therefore we could work on it. All right. So with windows joinery, there is usually, in terms of New Zealand Building Code compliance, there's B1 structure, B2 durability, and E2 external moisture. We focused on E2 because we know that's where council's concerns were, and partly B1 as well. So under E2, external moisture, the New Zealand Building Code, there's a whole bunch of different compliance pathways. The way we approach things is we want things to be simple and things to be done rather quickly for the client. So understanding the compliance pathways is, if it's a deemed to comply solution, which is the acceptable solutions, which is AS 1, 2, 3, 4, or verification methods, we try and go with the ones that requires us to do the least work, and that obviously is acceptable solutions. Preferably we avoid verification methods because that involves a lot of testing, and then that's another whole range of costs and technical data which we don't like to deal with. It can be quite expensive. So in terms of what's best for the client, we have to go with what is already deemed to comply, what's already available, what's something council also find familiar and is also able to work with. So I looked into these things and had to filter and eliminate, okay, based on this, which of these acceptable solutions do apply and which ones do not. So in that regard, acceptable solution 1, that's for timber frame buildings, it doesn't apply here, so that's ruled out. Number 2 is for earth buildings, so same thing, doesn't apply here, that's taken out. And acceptable solution 4 is for light steel frame buildings, so it left us with acceptable solution 3. So within that, we were able to work out then, I think Alia mentioned that there's a code of practice that's referenced in this acceptable solution. So we found a detail where the Windows joinery needs to sort of match and fit, and that's the path we took to demonstrate to council, hey, we've got a scenario which is very similar to this, and with just a few changes, it's very similar to this deemed to comply solution. So in a little bit more detail, so ultimately it is an alternative solution, but it is based on acceptable solution 3, which council is familiar with. It's from the New Zealand Building Code. The diagram I've put up there on the right is just an indication of the extent of tests that this particular window went through in preparing their test certificates. So when we received the same documents from the clients, and it was in German language, but based on a little bit of interpretation in Google Translate, there was a whole bunch of tests, and this is what I've summarized there. It's water tightness, air permeability, wind resistance, mechanical strength, thermal insulation, sound, so burglar resistance, and all these other ones. So that's a 30 to 40 page report, and instead of putting all my time and effort into that, I had to work out what does the New Zealand Building Code require, what does AS3 require, and so going back to what it requires, it was basically, look, this is the things that the New Zealand's specific performance standard NZS 4211 requires. It's about wind load, the deflection, the air infiltration, water penetration, and the wind load's ultimate strengths. So based on just those four, those are the 4 things I had to look for in those test results. But taking a step back, I'm not sure if anyone has dealt with it before, but sometimes when you get provided test certificates and test results, sometimes they are provided for by the manufacturer themselves. So there's no independence, so there's no impartiality. So one of the things I had to establish firstly, independently, was, is the certificate that I'm looking at, is that impartial? Is that reliable? Something I can rely on to know that what I'm looking at is not something that the manufacturer has paid for and produced as part of the marketing information. So going through that, identifying that is definitely independent, that the institution itself is also accredited. Those were the first few steps in establishing, I guess you could say, trust in in the test results. And then based on that, I could then have some confidence that, okay, I'm looking at certificates which I know I can rely on. And so then that became a process of quite a bit of work in terms of, as you can see from the tables, I had to translate and understand the German language. We had English versions as well, but some of the finer details were still in German. The client had, I guess, provided some assistance with some of the German language as well. So we appreciate that. So literally there was quite a bit of interpretation work in terms of translating from a foreign language to something the council here accept and understand, which is English. And I won't go through all of the details, but what the test certificates were showing is basically, if you look at the table on, I'm not sure if I can highlight it for you. Let's try and annotate. So let's go back. All right. I'm just trying to annotate the previous slide. Give me a second. Just going backwards. All right, slight technical error. All right. So the table that I'm going to show you over here. All right. So when we looked at test certificates, what I'm highlighting here in the blue circles is what was given. So they would say, okay, this meets the wind zone load that you require. It's a class B3, B2, whatever it is, C5. How does it translate to New Zealand? What does it mean to us? And I guess that's where the council was struggling to understand, okay, you've provided us the certificates, but what does it mean to us? What does it actually mean? Does it comply? I don't know. That's why we need you to tell us whether it complies. So going back to that, I think I've lost a bit of control there. The slide's got a mind of its own sometimes. All right. Hang on. Yeah, so going back to that, I had to then work out from the test results, because with the way the European tests were done, they would do a test based on a certain standard, and then they'd have a separate standard just for classifying the test results. So I had to look into that as well and understand, okay, you've given us a B4. What does B4 mean? What does A mean? So going through that and working it out and translating it into a format that council understands, I came up with basically an acceptance criteria and said, basically, look, if you're getting anything that's better than a B4 and a B3, it complies with a very high wind zone. And for air infiltration, if it's a class above 4, it does comply. And also with water penetration, if it's above 8A, which is fully exposed, then it's fine as well. So I guess a lot of effort was spent on this part just to show to council that, look, we have gone through the different steps to work out what the New Zealand standards require, and this is what the test results are. So mapping it out, this is ultimately what, no matter what product is specified, it needs to meet these minimum levels. So on that basis, whatever was specified by the architect, we just had to then cross-check that, okay, this is acceptance level. If it's above that, it complies. So that the process became simpler from then on. All right, so I guess that is the one that I spent the most time on. The easy part is what I'll describe next. Let's talk about it now. All right, so you had previously seen this slide before. One of the issues the council had is they said, look, okay, you've got a joinery unit here, but I don't know what happens when the water gets into it. What happens to the water? Does it get trapped? Does it drain out? We don't know this. We don't have evidence of this. Can you please show to us or provide the evidence that that is the case, that there is a drainage holes or slots for water to drain out? So I guess council found it difficult because the information they were given, they had a lot of marketing information and some brief installation manuals, but it didn't give them the information to I guess meet the reasonable standard that they're after. So I had to dig back and use a bit of German and find out from the manufacturers, and actually when they actually manufacture these windows, when they fabricate it, what's the instructions they're given, and so it needs to show where the water drains out. So I had to get the diagrams. I believe the best way to show council was with the visual representation. So I got these diagrams from whether it was the installation manuals or whether from the technical fabrication manuals. Then I said, look, this is the translation of it. This is basically showing this is how the water drains out, and council asked no further questions on that. So something visual, something very clear, showing the cross-section, showing where the holes are drilled. I mean, that's very clear about how the water is going to get out of the units installed. So that was quite easy to resolve. All right, the next one, I guess I'll make some reference to some of the drawings that Sang Architects had provided, because council will get those drawings and not what I'm showing you on the screen now. So when council receives the plans for consent, they show the units as they are assembled, as they are connected together. So when you looked at those diagrams, I guess council was looking at it the same way that I was. And I said, okay, why is council finding it hard? And the reason is they don't know where, I guess, the shutter ends, the roller shutter ends, and where's the interface to where the head of the joinery unit is. And they needed to understand, okay, so how do you stop water getting in? What's some of the features about this that stops water getting in from the outside to the inside? And so I had to go back to the installation manuals, which was provided, and then pick out the diagram that shows clearly the different units and how they interface. So I highlighted the diagram. I guess I zoomed in on it, and I used the arrows, same as you can see on screen here, to show to council, look, they've got interlocking the adapter profiles for them to fit onto different joinery units. And then when they interlock together, that alone itself will prevent water getting in. It's designed to be a weather-tight seal, and it's meant to be very easy to install. So it eliminates a lot of the work from some of the builders in terms of having to prepare a substrate and then getting it installed and using all kinds of sealants. So that was a way just to show to council, look, it's sort of inbuilt into the design, the fabrication of the product. So that addresses partly that as well. And now finally, I'll just talk about, a final review of the weather-tight details. I recall that we had talked about acceptable solution 3, and in the code of practice, it specified some of the key elements that needed to be met. So in that regard, when Alia had done her work with Stowe and with ProClimber, we went back to look at it and just to make sure that it matches it up and lines up with acceptable solution 3, the similar elements that's in place. So it was basically just a quick review from that point on. And I think Alia's already talked about this, the waterproof bandage, the profile tape, the base cap and the sealants, which is what we were looking for, which matches what I guess AS3 was looking at as well. And just very quickly, that's the head and this is the sill. Same, nothing too different about this. The only thing we had previously specified in a previous project was the sill tray and with the stop ends, so that was also in place in the details, and the rest of it Alia had also clarified as well. And just a few points on this. These products are brands appraised, so it makes it easy for council to accept, because they know, look, brands is an authority that does certify and confirms that it's suitable. The other thing was then that in terms of because it's an alternative solution, we had to support that with, I think Daryl had talked about it earlier, the Wellington project, that the details used here are similar to that. But not only that, I contacted the council in Wellington and asked them to provide something in writing. Look, that's been installed and it's been in service. Is it performing? And they provided something in writing, basically saying, look, this is a fantastic product. It exceeds the expectations. It's definitely performing, because that's the building they also go back to every now and then as a education for other designers and other consenting authorities. They say they use that as an example to show others that there can be better windows, better joinery systems in place. So on that basis, I think we are confident to say that what was specified is performing. So that was further evidence to some of the technical details provided already. And as Alia said, further to that, ProClimber also released the recent test results as well. So there's full confidence that what is provided is a tested system and it works. So that's how I guess we were able to convince council, look, these products we've looked at the past, we've looked at the present, we supported it with evidence as far as we can find, and this is the approach we've taken. So there's no reason why now that these windows cannot be installed in this particular window. So that's the approach we took to resolve the issues, and I guess that's the end of my presentation. So just a quick run through again, understanding what the RFIs are, where council is coming from, I guess looking at it from their point of view, what are they struggling with, and therefore how can it be made easier for them to understand and process, and therefore put the sign off on, and choosing a pathway that helps them realize, look, this is not too far off from something that already exists, and then just giving them all that evidence to say, look, they've given us the evidence we need, we can now sign off on it. So basically that's the process we took, and hopefully it's of assistance. That's all from me. Thank you.
Thanks so much, Ian, Daryl, and Alia. And just to quickly highlight, it came up on the screen earlier, I think in Alia's slides, the High Performance Construction Details Handbook, which is free to download from FINSA's site. And it is a compendium of previous details that have been consented in New Zealand. So if you're interested, please head over to our site and have a look. So if you have any questions you'd like to ask of any of the panelists, please pop them in the Q&A or the chat. Haven't got any questions through at the moment. Oh, yes, we do. Great. Thank you. Somebody anonymously saying great presentation. Thank you. So I have a question, and that is, can you tell us, if you had to choose one key learning, what would you bring to your next project?
Oh, that's for us. Okay.
Yeah.
Okay. I guess from my point of view, it's knowing that we have a process in place now. So if another foreign product comes into our job files, we know, okay, hey, wait, we've dealt with this before. It's about interpreting and understanding council's concerns, and just shortening the process, work out specifically how the product, where it applies, which is the solution that works best. And instead of looking at all the test data, just find the ones that matter the most, get those ones, so that we don't have to look through a whole bunch of information that does take some time. So shortening the process with something that we've done already, I think that's one of the key learnings. So that's why we're confident if somebody comes to ask us, you've done joinery before, how about this one which came from a different country? Can you handle it? We'll say yes, because this we know exactly what works now. Yeah.
I think, Amy, I could add to that. I think probably one of the biggest things with this scenario was the communication and the process. Being able to communicate with the builder and the architect, and everyone sort of working as a team collaboratively was great. And I think that needs to happen more in New Zealand. It doesn't happen enough. You tend to have an architect prepares drawings, you get a building consent, it gets given to the builder, the architect's never around, and no one really thinks about engaging somebody like a building surveyor to assist as well. And hence we end up with a number of defective buildings in New Zealand. So I think there could be a lot to be said for the process.
Great, thank you. Daryl saying, Alia, is anything you'd add to that answer?
I was just going to say there are a number of different kind of high performance window suites coming into the country. Some are brought in by suppliers. Some are being imported independently, and ideally you would try and deal with some suppliers have already pre-certified their windows and had them checked and kind of approved prior to installing them in buildings or putting them into projects. So that if someone already has been through that pathway, then that actually makes everyone's job when we're lodging building consents. It's a lot more straightforward.
Yep.
Yes, having all your certification in place up front would be really good.
Yep.
Helps everyone make everything go more smoothly.
Thank you. So here's one. If you could purchase New Zealand windows that meet this project's requirements, would you?
Yes, absolutely. I think there are more suppliers, manufacturers actually coming to the market in New Zealand, where they're either making high performance windows, passive house suitable windows from scratch here in New Zealand, or they're importing parts, frames, hardware, and assembling the windows here in New Zealand. So yes, and the people that are doing that, they already have their systems pre-approved, pre-certified. So it does make everything easier, more straightforward. So,
yeah.
Yes, absolutely. We'd love to work with New Zealand manufacturers.
Mm-hmm. Great. So here's a question. Did the BCA help you with the compliance path process? Were they interested in the passive house movement and keen to assist and help?
We were dealing with the particular BCA here is Auckland Council. I think there's a number of passive houses being done in the Auckland area. So they are starting to learn about passive house and all the systems that go with passive house. So I think everyone's learning about this as more and more get done and more houses get certified and approved, get granted building consent, then I think the whole process gets easier because everyone gets more familiar with it. But
yeah, I think also, sorry to add to that, we obviously have a pretty strong relationship with Auckland Council. So we also got involved when we needed to discuss things with them and talk directly with the processing officer and Ian did a lot of that, explaining the pathway and how he was going about things to sort of give them a bit of reassurance that it was the right process.
Mm-hmm. Oh, great if you've got those relationships.
And also, I'll just add on, when I contacted the Wellington processing officer as well, and asked about the performance, they were more than happy to volunteer and say, look, this is a fantastic project. They're using it as an example to teach others about, the benefits of Passive House. So that's why, they were confident to say, look, yes, this is performing, this is fantastic. It's a great design and it's working well. So we like Daryl said, we do work well with the councils, and we do ask them directly up front if there's any issues, and they will tell us.
Yeah. Okay. So for this next couple of questions, we might want to put the slides back up. I'll start reading it and we'll see if we can get to the right slide for it. The interior of the roller blind enclosure appears to have direct air contact with the exterior. This seems to show that the underside of the concrete lintel is completely without the exterior insulation layer. Is this not a reduction of thermal performance / thermal bridge? Are you able to answer that without the slide up, or do I need the slide?
That'll be a question for the other Daryl, I think.
Yeah.
Mm-hmm.
The shutter box on top of the window is it's fully insulated. So there's insulation on the. As we zoom up, yeah, you can see at the back of the slide. I don't know if you can see my cursor, but yes, it's a Passive House suitable shutter, and it has actually got full of insulation at the back here.
Right. And
yes.
another one.
And if I could add, oh, sorry, Amy.
Please.
Oh, yes.
Go ahead.
Yes, I was just going to add that the reason why we removed the insulation from the underside of the lintel is because we needed to have that direct fixing of the shutter box to the lintel structure. And as Daryl had explained, the shutter box itself has insulation on the inside because it's a Passive House certified product. And we have, I don't know if you could see that in the detail, but we have also allowed for flexible window membrane, Proclimer, Extora, Profil tape as a weather tightness and air tightness improvement measure at that junction between the shutter box and the lintel itself, also to improve the performance of that detail.
Thank you.
Thank you.
And another one where we might need to look at the slide. The head detail looks like a TB with the aluminium blind box in direct contact with ICF concrete core.
I think it's a similar question.
Right. Yeah. Okay. Haven't got any other questions that have come up at the moment. Is there anything anyone else would add to that? Add to in general? No. Okay.
I just
All right.
comment
Yes.
briefly on what Daryl August and Ian had mentioned in terms of the process of certification. And I would say that crucial to the success of this actually was the collaboration between suppliers and consultants, and approaching council, with this joint effort that made a huge difference for them to understand, rather than approaching suppliers and consultants individually, getting everyone on board and discussing the details, and achieving the details had helped actually a great deal to achieve that sort of balance between responding to E2 weather tightness and at the same time maintaining the integrity of Passive House design.
Wonderful. Thank you. Well, thanks everyone for your insights, and thanks everyone who's attended. If there's no more questions, I think we'll leave it there 5 minutes early, which is great. Everybody have a wonderful afternoon, and we'll see you hopefully on the next Passive House webinar.
Thank you.
Thank you,
Thank you, everyone.
Right.
Thank you, everyone.
Thank you, everyone.